Now, in a more general setting, you might be asked to draw the graph of some complicated exponential function, and you would figure out the graph of such a function by making use of the transformations. So let's say you're given this and you're asked to graph it and also find domain and range. Okay, so let's say those are the given questions. Let's try to figure this out. Now, in general, here's how I like to do things. In general, if you have like minus and then function, and sometimes you have minus in front of x, and then you have some number and another number like that. The way I go about it is first figure out what happens with this minus, and then think about these numbers. These are number 2 because those are the shifting. And then if there's a minus in front of x, I do that last. Okay, so this is a good order of doing things and figuring out order of operations. You don't have to follow that, but if you don't, then it just becomes harder. Okay, so let's do it that way. There's no minus here, so the first thing I want to do is think about this 1 and 3. So what I want to do is first I start with y equals 2 to the x, and then I put these numbers in, so y equals 2 to the 1 plus x plus 3. And then only after that I want to apply that negative and see what happens. Okay. First, this one. You should know that y equals to some function, some value a to the x always look like that as long as this is bigger than 1, with the horizontal asymptote being at the y-axis. And if you plug in 0, it's 1, so the y-intercept is 1. Now, think about 1 plus x as like x plus 1, right? So if you replace x by x plus 1, what happens? That's like shifting 1 to the left, right? And this plus 3 shifts everything up by 3. So what happens is this 0, comma 1, here is 0, comma 1. That goes 1 left, so it's negative 1, comma 1. But then you add 3, so it's negative 1, comma 4. So if I say this is negative 1, I'll probably want to make this bigger. Okay, so let's say this is negative 1. 1, 2, 3, 4. Negative 1, comma 4 is the graph that it passes through, right? And this horizontal asymptote now, because it's shifted up by 3, is going to be at 3. Okay, so this got raised up by 3. It also went left by 1 step, but it's a horizontal line, so if you go left by 1, it doesn't do anything, right? So I took this point, raised up by 3, went left by 1. I took this horizontal line, raised up by 3, and went left by 1. That's what I did. And then it's the same kind of graph over here. So I need to pass this, and it has to be graphed like that. Now, it's advised that you also have the y-intercept. So to find the y-intercept, what would you do? You plug in 0 here. If you plug in 0, 2 to the first power plus 3, that's 5, right? So you would have 5 here. Okay, so that's the graph of y equals to 2 to the 1 plus x plus 3. And now you've went from x to negative x. What kind of transformation is that? Well, if you think about it, here's x, y, negative y. Going from x to negative x makes the entire thing flip from the right to the left side, right? So what happened from here to there? Well, I can write it like this. First, this one is a transformation. Negative 1 step left and 3 up. And this is a reflection over the y-axis because it flipped over the y-axis. And the resulting graph will be still at 3 you have the horizontal asymptote, and it's going to pass through negative 1, comma 4. And at 5 you're going to have a y-intercept. So that's the graph. Okay, so that's how you would draw a graph of an exponential function as complicated like this by making use of all the transformations.